Hello everyone, how are you? How's everything? I hope everything is going well with you and you're ready for a new video and a new subject in the electronics course. So, today I'm going to just tell you a couple of quick things about the diode and we're gonna wrap up our diode discussions. One of the things that I wanted to tell you is about the small signal model of the diode. But what is the small signal model? Look, as you remember, the diodes, we can turn them on by applying 0 0.7 volts on the two terminals of that, right? Right at that bias point at 0 0.7, if we apply a little bit less or a little bit more, we can see a kind of behavior from the diode that the current will change slightly when the bias point is moved, for example, between 0.69 and 0.71, for example, a very slight change as I'm showing in this picture. If V is changing a little bit around 0.7, speed is 0.7, I is also changing a little bit. So when I is changing with the change of the V, it means that there is kind of a resistance there. So this is how we model our diode in the presence of an AC signal with a resistor, and we call it RD because of this behavior that it shows. So if there was a circuit that apart from the DC signal that is biasing the circuit had also a small signal AC as well, we have to replace our diode with a resistor. How? Okay, imagine we have this circuit right here in the top. There is a DC source, there is an AC source, there is a resistor, and there is a diode in this circuit. So how do we model this circuit to take into consideration the AC signal here and the diode here? There are a few simple steps that we use. These simple steps are called the small signal model of the diode. This way we can analyze this circuit in AC as well. So first of all, we should know that, as I mentioned right now, we should know that in AC we can replace the diode with a resistor called RD. What is the value of RD? The value of RD is VT over ID. But what is VT? VT is a constant. VT is 25 millivolts most of the time, like the temperature dependent constant and these things, but you imagine that you always know to imagine it's always 25 millivolts, okay? But how about ID? ID is found by removing the AC signal, okay? So just keep the DC like this. So look, this circuit, I model it into this one. So I remove the AC signal. Then there is only one battery, one DC battery, and my resistor is still here, and I replaced my diode with a 0.7 volt battery. Why? Because we imagine that the DC signal is big enough so it can turn on the diode. Of course, the diode will be modeled with this wire and 0.7 volt, that is the voltage drop on the diode. So in this case, in this signal, in this case, the ID will be VDC minus 0.7 over RT. So here it's written by mistake VT. So we'll fix it right now. So yes, it will be VDC minus 0.7 over R. This will give us the ID, and from ID we can find RD. This RD is gonna be VT that I said is most of the time, it's almost all the time, let's consider always, the value of RD is simply 25 millivolts over ID. It will give us RD, and this RD is going to serve as the replacement of the diode in AC model. So this circuit turned into this circuit. So let's go over the steps once again. Step 1, when we have a circuit like this, step 1, we ignore the AC signal, right? We ignore the AC signal. So for the fully DC, we will find the current in the circuit, and of course when we're finding this one, the diode is just, we assume that the diode is on and we have 0.7 volt drop on the diode. And after we found ID, then we will ignore the DC signal. As you see here, the DC is not here anymore, and then we will replace the diode with RD, where RD is simply VT over ID. So as simple as that, you can model your diode in AC. So if you go to the lecture 15 that I posted on Moodle for you, the steps are also written here at the end. So first neglect the AC, find ID, then neglect the DC and replace diode with RD. And then you can perform the small signal analysis. So that was the main thing that I wanted to tell you, and I wish you a beautiful day. So please come back if you have any questions to the online session, and if you want we can solve an example or two over there. Thank you very much. Have fun. Take care.